Hello everyone. In this video, I'm going to explain the microarchitecture library that is developed in VisualSim. Purpose of the library. Designing a processor at cyclocurrent level requires detailed specifications about the instruction set architecture and the hardware components. VisualSim provides the ability to design and analyze both the ISA and the internal hardware devices. User can utilize the existing ISA or they can design their own ISA for a custom processor. With VisualSim, user can determine the behavior and usage of each instruction that can be processed by the pipeline stages. Designing a high-performance processor requires recursive analysis to select the optimal configuration. VisualSim provides the hardware libraries for pipeline stages, interconnects, and memory devices that can be configured as per the device specification. Based on the simulation results, user can fine-tune the configuration to improve the system's performance. The analysis that can be done. For a processor design, the designer wishes to analyze the CPI of the implemented hardware for a specific workload. VisualSim provides detailed statistics for like performance statistics and debug informations to analyze and optimize the system. The key statistics includes the CPI, memory access latency, total number of instructions executed, and the total number of instructions committed. Designer can observe the resources such as utilization and occupancy to improve the hardware design. Along with apart from performance analysis, the VisualSim provides the ability to design and analyze the power consumption of each device as well as the entire system. VisualSim has a hybrid processor library and a microarchitecture design library. Both are used for emulating the processor, but each has its own purpose and advantages. The hybrid processor library performs trace-based execution, while the microarchitecture library performs dynamic instruction scheduling, actual instruction execution, and the branch flow handling within the pipeline stages. The hybrid processor library will be beneficial for someone who wishes to analyze the devices and operations that are external to the processor, such as memory access performance, interconnect performance, DMA operations, and IO accessing and all. The microarchitecture library focuses on detailed analysis and improvements of the internal processor design along with the external hardware. With microarchitecture library, the designer can observe the actual values being read or written in the registers and memory. The instructions that are being processed and propagated through the pipeline stages can also be observed. They can also observe the functionality of the each pipeline stages, such as during the execution, such as buffer occupancies, flushing, stalling, and resource utilization, and etc. Now let me open a demo model to demonstrate the behavior like implementation of the microarchitecture library. This is the architecture view of the ARM Cortex A77 processor using this microarchitecture library. Let me run this model to observe the statistics. So the simulation is completed. We can observe the final CPI of the entire run is around 3.59. And the total number of instructions committed is around 45,000. Also, the number of instructions executed is around 56,000. These are the instructions that are executed speculatively using the out-of-order configuration. We can also observe the total micro-ops that are scheduled and the number of macro instructions that are converted into micro-ops. The user can also observe the number of instructions executed in each functional unit and the average utilization of the same. One of the important features of VisualSim is the power analysis. We can see the power plot that shows the instantaneous and average power consumption for the entire design over the simulation. These are obtained based on the values configured in the power table. Along with this, user can observe the executed trace for the source code and the final values updated in each register. During the simulation, we can observe the performance of the pipeline by checking average CPI plot. It describes the time period where the performance is getting increased or decreased. The memory hierarchy plays an important role in processor design. These can be analyzed through the statistics generated over the simulation, such as the cache hit miss ratio, throughputs, and the write backs and evictions, and the utilizations. So similarly, we can observe the statistics for the DRAM and the interconnect devices. Apart from this, the microarchitecture library support the debug features to validate the internal functionality of each pipeline stages. These can be enabled using the debug enable function. Similarly, user can observe the actual behavior of each instruction to validate the correctness of the ISA by enabling this behavior debugging option. We support separate libraries to model the RISC-V architecture. The user can observe a similar structure and configurations. The key difference is the internal logic is implemented according to the RISC-V architecture. In order to run any source code through this microarchitecture library, the user has to update the trace file that can be supported by this library. In order to run any source code through this assembled pipeline, user has to generate the disassembly file using this specific ARM compiler or the RISC-V compiler. This is an example to describe the source code is compiled using this ARM compiler to obtain the generated disassembly. Once the disassembly file is obtained, the user has to pass the file using the Python script to generate the disassembly trace that can be fed to the microarchitecture library.